It is my pleasure to welcome you to the Natural Areas Association, Nature's Frontline, the role of natural areas in climate resilience in the Central Appalachian Forests. I'm Lisa Smith. I'm the Executive Director of the Natural Areas Association, and I'm being joined today by my colleagues, Maura McGinty-Kloss, Director of Programs and Communications, and Amy Wills, Director of Operations for the Natural Areas Association. And I just want to thank you for joining us for this virtual program. And while we are so excited that we to once again be convening in-person events, we're pleased to continue offering virtual programming because we strongly believe that good science and collaboration must be available to everyone and not just to those who have the time, ability, and means to travel to an in-person event. So welcome to our virtual event today. I'd like to give a special thanks to the Colcom Foundation for providing important underwriting to make this symposium possible and affordable for all of us today. So thank you to the Colcom Foundation. And for any of you that are new to the Natural Areas Association, I'd just like to take a quick minute to tell you a little bit about us. We're a national nonprofit organization that serves practitioners who manage ecologically significant landscapes in order to protect biodiversity. We contend that protecting these natural areas in perpetuity requires quality science to inform practices and access to reliable resources. Given this, we provide science-based content for practitioners and researchers, those seeking applied science, practical solutions, and knowledge related to the management of biodiversity and ecologically significant lands and waters. We do this by utilizing a suite of programs, products, and services that allow us to address a broad spectrum of current and emerging issues, methodologies, and best practices in a manner that's useful and convenient for busy practitioners. Our programs are designed to achieve on-the-ground outcomes and to encourage practitioner participation, especially with one another. Climate change is the great multiplier in natural areas management, exacerbating the impact of other ecological stressors. This concept is not new to NAA, and climate change-related talks have been prominently featured at our conferences and in other programming for a long time. The basis of this program began several years ago, but as with many things, COVID-19 delayed making it a reality. In 2019, attendees at our Natural Areas Conference met in Pittsburgh, Pennsylvania, to consider the role that natural areas related to mitigating the impacts of global climate change while adjusting approaches to land management to confront ecological stresses. At the time, this was an emerging area of science, creating more questions than answers. The conclusion was that practitioners need to know more about the role of natural areas in a changing climate and whether it's possible to make the case for natural areas as the front line in the battle to preserve biodiversity, create climate resilience, and mitigate climate impacts. Today's symposium will consider the role of natural areas as a critical strategic component to mitigating impacts of human-caused climate disruption. The purpose is to examine the science and equip practitioners with the information they need to inform management plans, educate policymakers, and enlighten the public on the vital role natural areas play in offsetting the impacts of climate change on our planet. We, all of us, are a community of people who are most in tune with what is happening on the landscapes in which we work. So it's incumbent on us to be a voice in this global conversation. We'll also explore management techniques that maximize the resilience of natural areas to better protect biodiversity, sequester carbon, and maintain valuable ecological services. This is an ongoing conversation, and we're looking forward to continuing it beyond today. Two people that were part of the 2019 Natural Areas Conference and leaders in those discussions back then were also instrumental in developing this program and agenda for this symposium. So I'd like to have a big shout out and give a sincere thanks to Ephraim Zimmerman, the Science Director for the Pennsylvania Natural Heritage Program at the Western Pennsylvania Conservancy, and Charles Beer, the Senior Director of Conservation Science at the Western Pennsylvania Conservancy. Without their vision and support, this program would not have been possible. So we're also grateful for our speakers today. Everyone on this agenda is a thought leader in connection to this topic, and we are eager to learn more from them individually as they engage with each other during the concluding panel, especially. As we all know, this is a complex topic that involves many different dynamic systems, and we will not leave today with all of the answers. However, when we do gather and learn from each other, we make great progress and we gain insights that can be integrated into our practices. NAA is proud to be the convener of programs like this symposium that can contribute toward climate resilience and the preservation of these very special places. Now it's my pleasure to introduce our opening speaker and the facilitator for today's program. Our facilitator today is Dr. Ryan Klopf. Ryan is a member of the NAA Board of Directors and is the regional supervisor for the mountain region of the Virginia Natural Heritage Program. Additionally, he serves as the Natural Areas Science Coordinator for the state of Virginia. Ryan works to protect and restore rare species and natural communities within the Ridge and Valley, Blue Ridge, and Piedmont regions of Virginia. He earned his BS in biology at William and Mary and MS and Ph.D. in plant biology from the Southern Illinois University. Ryan brings a very unique perspective to this event and many NAA initiatives as he effectively works in both realms of our work, the science and the practice. Ryan will bring thoughtful facilitation to today's symposium. But before I hand the symposium over to Ryan, I'd like to introduce our opening speaker, Dr. Reed Noss. Dr. Noss is well known to many of you. He is a writer, photographer, lecturer, and consultant in natural history, ecology, and conservation. He was the former Provost Distinguished Research Professor of Biology at the University of Central Florida. Reed earned his Ph.D. in wildlife ecology from the University of Florida, served as editor-in-chief of Conservation Biology, science editor for Wild Earth magazine, and was president of the Society for Conservation Biology. He is an elected fellow of the American Association for the Advancement of Science. His recent research topics include disturbance, especially fire disturbance, ecology, ecosystem conservation and restoration, road ecology, and vulnerability of species and ecosystems to climate change and sea level rise. He has more than 340 publications, including 8 books. Reed is also the chair of our NAA's Science Advisory Committee that includes some of North America's leading authorities on the conservation of biological diversity. The Science Advisory Committee advises the Natural Areas Association, Board of Directors and our staff on developing critical issues regarding the identification, protection, restoration, study, public use, and stewardship of natural areas. Reed is participating in the symposium. However, he did pre-record his opening remarks, Natural Areas in the 21st Century. This is based upon a publication of a topic authored by the Natural Areas Association's Science Advisory Committee. Reed's here to share some of this with you today. After Reed's pre-recorded presentation, Ryan will go ahead and take over facilitation of the agenda at the rest of the day, and I'll see you at the end of the day.
Good morning. I'm Reed Noss. For the last couple of years, I have served as the chair of the Natural Areas Association's Science Advisory Committee. The other members of our committee are Greg Aplett, Pat Comer, Carolyn Enquist, Jerry Franklin, John Riley, and Hugh Safford. We were assembled to advise the board and staff of the association about what current science has to say about the role of natural areas in society and to provide guidance to natural areas practitioners regarding major challenges to the ecological integrity of natural areas. We recently submitted to the board a somewhat lengthy report entitled Natural Areas in the 21st Century. What I'm going to do this morning is read you that entire 83-page report. No, just kidding. What I will do is summarize parts of it regarding the role and management of natural areas, especially with regard to the challenge of climate change. The Science Advisory Committee noted that the natural movement in North America began with Victor Shelford, the first president of the Ecological Society of America, who in 1917 established a Committee on the Preservation of Natural Conditions. The mission of the Preservation Committee was to establish, quote, a nature sanctuary with its original wild animals for each biotic formation. This is an early expression of the ecosystem representation goal which is central to conservation planning still today. These sanctuaries were intended to allow scientific research in areas as free as possible of human influence, so we could determine how nature works without our influence. In addition to representing all types of ecosystems in protected natural areas for scientific research, our committee recognized several other fundamental roles of natural areas, particularly one, as places to protect biodiversity, often with emphasis on imperiled and vulnerable species and natural communities, endemic species, and often disjunct and peripheral populations. Number two, as benchmarks or control areas for scientific comparison with anthropogenic or other strongly manipulated areas. This role is actually implicit in the ecosystem representation goal. And third, as places to maintain other important societal values, including water quality and historical, cultural, scenic, and recreation values. Our report then discusses in some detail the challenges to natural areas in the 21st century, especially land use, land cover change in the landscapes surrounding natural areas, climate change, non-native species invasions, and changes in natural disturbance regimes. Today, I focus on climate change, but all of these are somewhat related. One crucial consideration is that climate change today is occurring in landscapes that have been highly fragmented and degraded by human activities. Species that once could have tracked shifting climate zones through natural dispersal can no longer do so in many cases. They must now attempt to disperse across landscapes containing fragments of natural or semi-natural areas, and the landscape matrix itself is occupied by various human land uses that create movement barriers for many species. Also, many invasive non-native species may fare better than native species under future climate scenarios, largely because invasive species typically have high dispersal capacity. What is especially challenging for land managers is that many of Earth's ecosystems are undergoing major transformations with uncertain endpoints. Ecosystem transformation can sometimes be rather abrupt, as when an ecosystem passes some tipping point or is subjected to a major disturbance and flips relatively quickly into an alternative stable state. An example of this is a fire-excluded pine savanna becoming increasingly less combustible as mesic hardwood trees with non-flammable leaves invade and gain dominance, while grasses and other flammable ground cover diminishes. Eventually, a point is reached where the community will not burn, except perhaps a small distance in from the edges or during extreme drought. Alternately, a woodland or shrubland may convert to a grassland after invasion by flammable non-native annual grasses and an increase in fire frequency. Other transformations are more subtle and occur gradually as the ranges of species shift in response to climate change and new sets of species begin to dominate the community. Such changes are generally adaptive and ultimately must be accepted by natural areas managers. One well-accepted framework for addressing climate change, called Resist, Accept, Direct, or RAD, recognizes three basic strategies: resist change, accept change, or try to direct or guide change in a desirable or at least tolerable direction. Resistance is the most common strategy applied today, as natural areas managers struggle to maintain ecosystems in their historical states or restore them to those states, even as climate change makes that increasingly difficult. Interventions to resist change can succeed for a while, perhaps for decades, especially if microclimatic refugia are available. And they are often appropriate when the existence of globally imperiled communities and species is at stake. The second option, accepting change, also has considerable value in many cases. One example is where an essentially unmanaged natural area undergoes substantial alteration with climate change, or perhaps worrisome Those changes are very informative for comparison with natural areas that are actively managed either to resist or direct the impacts of climate change. For instance, towards transformation to a novel ecosystem. Essentially, the natural area, the unmanaged natural area, serves as a benchmark or control area for management experiments. Our committee suggested some best management practices or guidelines for addressing climate-driven environmental change in natural areas. These include the following. Rather than only considering climate exposure in assessments of vulnerability to climate change, as is often done, also consider the two other components of vulnerability, sensitivity and adaptive capacity. Adaptation should be understood in a broad sense that includes evolutionary, ecological, and social changes that are likely to reduce the vulnerability of ecosystems to climatic disruption. Recognize that climate change is not just a long-term gradual threat. Rather, changes in the frequency and magnitude of climatic extremes are an immediate threat, and major disturbances linked to climate change may result in drastic near-term change. Wherever possible, identify and protect climatic refugia, which range in spatial extent from small localized habitats such as sinkholes, seepage areas, north-facing slopes, and some edaphic communities, up to entire landscapes with relatively stable climates due to topographic heterogeneity, proximity to moderating ocean currents, disturbance regimes such as frequent fire that produce resilient ecosystems, and other factors. Give greater consideration to the roles species play in the functioning of your targeted ecosystems. Which are the nitrogen fixers? Who are the pollinators? What species provide the physical structure or some keystone function in the community? While one might anticipate that species may be lost over time, maintaining or restoring diversity among functionally significant species groups will reduce your risk. If or when resistance becomes futile, managers should still collectively try to prevent extinctions of any species, in part because the future roles of species in ecosystems might be different from what they are today. As Aldo Leopold put it, to keep every cog and wheel is the first precaution of intelligent tinkering. This will require coordinated actions among managers in different locales, for example, to facilitate range shifts and response to climate change. It may also require keeping species in captivity, such as zoos or botanical gardens, at least temporarily. And it may require assisted migration or colonization, where populations are translocated to areas that are becoming more suitable than their current ranges to climate change. However, assisted migration should only be attempted after a thorough assessment is made of the risks, feasibility, and likelihood of success, as well as potential impacts to the recipient ecosystems. With species dispersing to newly suitable habitats, the definition of what is native to a region must be reevaluated. As pointed out by Moore and Schindler in a recent paper, quote, species movement into new habitats has always been key to the biosphere's adaptive response to a changing world, and protectionist perspectives could hinder community adaptation. Perhaps if species are following their projected climate trajectory, then they should be considered proactively native. For directed change interventions, the most defensible endpoints are usually those that are predicted by the best available climate science for the region in question. Encouraging development of ecosystems that are compatible with projected climatic and disturbance regimes is a wise strategy. It is important, however, that managers understand that such projections are hypotheses, and such interventions are best carried out in an experimental fashion within a bet hedging philosophical framework. Managers should consider creating experimental adaptive management portfolios, which include combinations of resistance, acceptance, or intervention-free control areas, and a suite of directed change interventions. Based on the experiments, those interventions or lack thereof that lead to unacceptable results are abandoned, and those that produce acceptable biodiversity outcomes are continued. Rather than focusing solely on the direct impacts of climate change, recognize that climate change interacts with other threats, such as land use change, invasive species, and changing disturbance regimes. Avoid simplistic solutions to climate change, such as massive tree planting for carbon sequestration. Afforestation of natural and semi-natural grasslands is a major threat to biodiversity globally. Natural areas professionals should be outspoken opponents of such popular but naive programs. Geophysically or geoclimatically diverse landscapes with heterogeneous topographic and edaphic conditions offer opportunities for species to adjust to climate change by moving relatively short distances into newly favorable habitats. Therefore, establishment of new protected areas should seek locations in these kinds of landscapes. Conservation strategies under climate change should be diverse and based on a simultaneous evaluation of conservation values and climate vulnerability. For example, areas with high conservation value and low climate vulnerability may offer the most promising opportunities for new protected areas, whereas areas with high conservation value and high vulnerability are more challenging to manage and will require maintenance of connectivity and protection from additional stressors such as intensity of development or resource extraction. So those are our recommendations with respect to climate change. Simple and easy, right?